let's see how acceleration due to gravity varies with depth. Now, what we'll consider? So, we'll consider some acceleration due to gravity on the surface of Earth. See, when I say some acceleration due to gravity, we already have a formula, which is G is equal to gme divided by re square. Correct? Now, see, assuming Earth to be a sphere of radius re and uniform density rho. So, we get mass is equal to 4 by 3 pi re cube into rho, because mass is what? Volume into density, correct? So, this is why what we get. So, we have G is equal to G into 4 by 3 pi re cube rho divided by re square. So, we get G is equal to 4 by 3 pi into G into re into rho, right? So, this is one of the equations. See, now what we'll do is we'll take the object to a certain depth x meter inside the Earth. So, from the center we can take this as re minus x, because the total distance is re. From there I am going down by x meters. So, we'll have re minus x, correct? So, what we are looking at is we are looking at a point re minus x from the center of the Earth, correct? Now, for this again we will have to calculate the acceleration due to gravity, right? So, we will have to consider Newton's second law and Newton's law of gravitation. So, we have F dash is equal to m into gx, is the force, and F dash is equal to g m dash m divided by re minus x whole square, correct? So, we get gx is equal to gm dash by re minus x whole square, right? What we have, remember, we are looking at a point where we can write a sphere, correct? So, since it's a uniform sphere, the density will be same. So, we get m dash is equal to 4 by 3 pi into re minus x whole cube into rho, the mass. So, we have gx is equal to 4 by 3 pi into g into rho into re minus x. Now, see, lots of variables are there. So, let me just go through simply like what is happening. First, we are looking at the surface, then we are looking at some depth of x. Fine. At the surface, we have a sphere, that's Earth basically. So, we calculate the mass. Then, we come down to by x meter. There, we have another sphere, we calculate the mass of that. Fine. And we have the acceleration due to gravity at both the points. So, now we divide one equation by another equation. That is, we'll do gx divided by g, then we'll get re minus x divided by re. In other words, we can write gx is equal to 1 minus x divided by re into g. Fine. So, this is the formula to find the acceleration due to gravity at certain depth. Now, as the value of x increases, the acceleration due to gravity decreases, meaning the more and more, the deeper you go, the acceleration due to gravity keeps on decreasing. Fine. Now, if we have to write a graph, see, the graph looks something like this. See, from at the center it's 0. Now, it keeps on increasing till it reaches the surface of the Earth, which is maximum. Then, again, it drastically decreases. So, this is the graph, and the formula how it varies with respect to depth is gh is equal to 1 minus x divided by re into g. So, keep these two formulas handy. One is with respect to the altitude, another one with respect to depth. So, after this, we'll solve few problems based on these two formulas.